What if we told you that a cosmic catastrophe occurred 2 billion years ago? In fact, experts have discovered that our Milky Way still had a little sister back then, which was then torn apart and destroyed by the Andromeda Galaxy. But even aside from this cataclysmic event, our galactic neighbor keeps surprising experts. You have probably already heard that the Milky Way will collide with Andromeda in about 4 billion years. But amazingly, the latest models now paint a very different picture in this regard, and the chances of us completely avoiding the collision are actually not bad at all. Did you know that you live next door to a cannibal? Well, be careful before you start questioning your neighbor's eating habits. Let it be said that this only applies to your galactic neighborhood. As is well known, the Andromeda Galaxy is the closest sister to our Milky Way. And while the word closest in this context still means a proud distance of 2.5 million light-years, Andromeda is also the most distant object from us that can still be spotted with the naked eye in the night sky. No wonder, since our neighboring galaxy has a diameter of 200,000 light-years, which makes it about twice as large as our Milky Way. But when it comes to the question of mass, experts' estimates sometimes vary considerably. While our home galaxy contains about 1.5 billion solar masses, the suspected values for Andromeda vary between 700 billion and 2.5 trillion solar masses. Although the latest findings, based on the movements of fast Andromeda stars, suggest that the two galactic associations have approximately the same mass, the question of mass remains controversial. What is no longer disputed, however, is the fact that Andromeda has literally gorged itself on a good portion of its current mass, namely by colliding with other galaxies multiple times over the course of history and then swallowing them. We have Eric Bell and Richard D'Souza from the University of Michigan in Ann Arbor to thank for discovering this case of galactic cannibalism. According to them, the experts had what the background is to the surprisingly metal-rich stars that lie dormant in the halo and in a gigantic stream of stars in Andromeda, and can also be found in one of its small companion galaxies. And surprisingly, it turned out that all the structures examined show characteristics that point to a common origin. Could they be the remnants of a cataclysmic galaxy crash when the sister of the Milky Way was devoured by Andromeda? Well, in fact, the answer to this question was ultimately yes. And in detail, the collision partner at that time was by no means just some puny dwarf galaxy, but the third big player in the local group, behind Andromeda and the Milky Way. Christened M32P, the galaxy is thought to have had around 25 billion solar masses. For D'Souza, it was downright shocking that we overlooked the former existence of the Milky Way's sister for so long. But now we know, as the scientists determined, M32P had already fallen into Andromeda's gravitational grasp 5 billion years ago, setting the stage for a cosmic catastrophe that was consummated 3 billion years later. Because after the third largest galaxy in the local group was pulled apart and torn into its individual parts due to gravitational effects, it was ultimately completely destroyed and absorbed by Andromeda. As mentioned, the traces of this cannibalistic feast are still visible today in the form of the strikingly metal-rich stars. But in addition to this, experts concluded that the companion galaxy under investigation, the dwarf galaxy M32, had once formed the centerpiece of the destroyed structure. In fact, M32 is an astronomical anomaly. Although it initially resembles a classic old elliptical galaxy, it also has countless young stars and astonishing compactness. As a result, the compact core of the galaxy should have survived the tryst with Andromeda largely unscathed. But at the same time, the study of the collision opened up a completely new line of research. Until now, experts believe that collisions between such massive galaxies always plunge the stellar disk of the larger crash partner into chaos. But that was simply not the case with Andromeda. However, the incorporation of M32P did not pass without a trace. The devoured galaxy set an immense wave of star formation in motion, during which around 20% of its stellar mass was reformed. So, will the Milky Way be spared a crash after all? The bottom line is that the collision with M32P was not an exception for Andromeda, but rather a common pattern. In detail, our neighboring galaxy has a much larger and significantly more complex halo than the Milky Way. This means nothing other than that it has probably come into close contact with other galaxies several times in the past. In this regard, the researchers found that two very different populations of globular clusters exist in Andromeda's peripheral regions, rotating perpendicular to each other. In conclusion, astronomers assumed that Andromeda has already experienced two major episodes of cannibalism, which probably occurred several billion years apart. And while the sister of the Milky Way was swallowed in the second episode, which may have occurred only a little over 1 billion years ago, the first could have happened as early as 10 billion years ago. If we draw a parallel to our own galactic home at this point, the question inevitably arises as to what fate the Milky Way will actually suffer when it collides with Andromeda in about 4 billion years. Well, or at least one might think so. But in fact, this question is currently rather secondary. In fact, the latest models suggest that the collision of the galaxies is much less likely than previously thought. But how did it come about in the first place? It has actually been considered certain for a long time that our galactic neighbor is moving toward us at a speed of 266 kilometers per second, and that the halos of the Milky Way and Andromeda, which extend far into space, are already touching. In view of this, the opinion has been established that the two structures will merge into Milkdromeda one day in the distant future. That is, into a new elliptical galaxy whose name consists of the first part of Milky Way and the end of Andromeda. This idea is not exactly new. The American astronomer Vesto Slipher had already discovered the possible collision course for the galaxies in 1912, after he realized that the light from Andromeda had shifted blue in the spectrum as a result of its approach. However, critics of the predicted Andromeda-Milky Way collision point out that the two galaxies are not alone in their cosmic environment, and that we should by no means underestimate the influence of the other structures. First and foremost, the Large Magellanic Cloud and the Triangulum Galaxy should be mentioned here, which, contrary to their names, are also galaxies. Added to this is the fact that the actual masses of the galaxies in the local group have been re-evaluated in the course of more recent studies. So how do all these factors affect the crash of the Milky Way and Andromeda? Well, a team of experts from the University of Helsinki has now addressed precisely this question, and the result is extremely surprising. To estimate the masses, motions, and gravitational interactions of the four galaxies involved, the researchers drew on observational data from the Gaia and Hubble space telescopes. They then fed the information into a computer model that ran through a series of possible scenarios. And lo and behold, if the Milky Way and Andromeda were to move freely through space without any external influences, their current course would lead to a collision in almost 50% of all conceivable scenarios. If we only consider the Triangulum Galaxy, the probability of a collision increases to 66%. After all, it will merge with Andromeda before the big crash, and thus push it even further in the direction of our home world. However, the situation is somewhat different if we now also include the Large Magellanic Cloud. Since it's moving perpendicular to the Andromeda-Milky Way collision course, it's likely to deflect our home galaxy in the event of a collision. In light of all these factors, the researchers ultimately concluded that the merger of the galaxies does not appear inevitable, but that the chances of it happening are only 50/50ths. In other words, the probability of a collision is just as great as that of the collision not happening. So, we're dealing here with a galactic coin toss. However, if the coin ultimately indicates merger, according to the scientists, this will not happen in around 4 billion years as previously assumed, but instead in 8 billion years at the earliest. In the same breath, however, the researchers emphasize that the last word in the Milkdromeda discussion is far from being spoken. Since there are currently still some uncertainties regarding the positions, masses, and motions of the galaxies under investigation, there is still plenty of scope for drastically different results. In order to be able to make even better predictions, the experts are currently waiting for the latest data from the Gaia Space Telescope. This has only recently been recalibrated, and future investigations should continuously refine the following models. But at some point, according to current scientific theory, all the galaxies of the local group will collide and merge anyway. Whether there will be anyone left to witness this event, however, is questionable to say the least. After all, The collective fusion of the worlds is expected to take a time that exceeds the current age of the universe many times over. Fortunately, the collective merger of the thumb and the subscribe button only lasts the blink of an eye. So feel free to like and subscribe to our channel Digital Discoveries, so you'll never miss a new video from us again. We'll see you soon.